Alright guys, on these next two problems we're going to look at the limit definition of a derivative from the formal form and then from the definition as it approaches a certain point, so that it would be like the alternate form. So if I look at my first example, I have 1 over x, and I'm not actually given a specific point or like a position to where it's going towards. So I do not need to be using the alternate form. I need to be using the formal definition of a limit. So I'm going to say here, or formal definition of a derivative, I'm going to say f prime of x equals the limit as h approaches 0. And I'm just going to substitute into this formula. So I'm going to have right here 1 over x plus h minus 1 over x all over h. Now, after I get this done, I need to just use basic algebra and combine like terms. So I'm just going to continue on with the same trajectory here, first by finding a common denominator. So this guy, we're going to be multiplying by x plus h over x plus h. This guy, we're going to be multiplying by x over x. And I'm going to rewrite that notation, the limit as h approaches 0. And then we're going to have 1 minus, or x minus h all over x times x plus h. And that's all over h. And so I can multiply by 1 over h. Now let's get a little bit more room here. Keep on with that notation. So the limit as h approaches 0, because I still haven't substituted for h yet, so that still needs to be involved. These x's cancel out, these h's cancel out, so you're left with a negative 1 over x times x plus h. And now I can substitute in 0 for h. And when I do that, I know that after I use that substitution, or that 0 gets plugged in for h, that cancels out, and I just get negative 1 over x squared. And I don't need to write that limit notation anymore because h has been plugged in at this very last step. So I can say f prime of x equals 1 over x squared. All right. This next guy right here, we are looking for the value at 3. With a quick substitution, I can actually get that ordered pair. And I know that ordered pair I'm talking about, 9 minus 12 plus 4, should be 3, 1. Whoops. My screen moved. Should be 3, 1 right here. So let's get that written in. And since I'm looking at a specific ordered pair, I'm actually going to scroll up right here and I'm going to be using this alternate form. So we have f prime of c is the limit as x approaches c of f of x minus f of c over x minus c. So let's just kind of get that written out. I know that f prime of 3 is going to be the limit as x approaches 3 of x squared, which is f of x, minus 4x plus 4. So all of f of x minus f of c, so that's that output, or that positive one. And then that's all going to be over x minus c, or x minus 3. Now when I get to this point right here, I'm going to rewrite because I still haven't substituted. So the limit as x approaches 3. We have x squared minus 4x plus 3. And actually, I'm just going to go ahead and factor that out. That's going to factor 2, x minus 3, x minus 1, and that's all over x minus 3. Now, if I were to plug in or substitute 3 right now, you would see that I'd be dividing by 0. So it's not an indeterminate form, but it's an undefined. So let's get that crossed out. And now I have the limit as x approaches 3 of x minus 1. And then I can just say that this is equivalent to 2. And we are good to go.